Hello everybody. In this video we're going to go through Vertex, Focus and Directrix of parabolas. I made a detailed chart for you here and let's go examine that. If our equation is in the form of x minus h squared equals to 4p times y minus k, and if our p-value here is positive, then our parabola is opening upwards. Our focus is inside of the parabola. Our directrix is behind the parabola. This is our vertex. And axis of symmetry is a line passing through focus and vertex and dividing the parabola evenly. Let's label. This is axis of symmetry. This is focus. This is vertex, and this is directrix. From focus to vertex, it is p units away, and from vertex to directrix, p units away. So directrix and focus is equally away from vertex. Equation of directrix, in this equation, it's a horizontal line, so y equals to some number. Axis of symmetry is a vertical line in this situation, so x equals to some number. From focus to the left is 2p unit away, and from focus to the right 2p unit away. This totally 4 unit away, and it is called focal diameter. So this is focal diameter, or latus rectum in other words. Let's go ahead and see if p is negative. If p value is negative, then our parabola is looking downwards. Again, our focus is always inside of the parabola, and our directrix is always behind the parabola. Our axis of symmetry is passing through focus and vertex and cutting the parabola evenly. This is our vertex. This is our focus, this is our directrix, and this is our axis of symmetry. Axis of symmetry is a vertical line, so x equals to some number will be the equation. Our directrix is horizontal here, so y equals to some value. Our vertex is h, k, negative h, k in the equation here. Our focus is p unit away from vertex, and our directrix is p unit away from vertex. And this is our focal diameter. 2p to the right, 2p to the left. If our equation is in the form of y minus k squared equals to 4p times x minus h, and if p value is positive, then our parabola is opening to the right. Our focus is always inside of parabola. Our directrix is always behind the parabola. And our focus is p unit away from vertex, and our directrix is p unit away from vertex. So this is our vertex, this is our focus, this is our directrix, and axis of symmetry is the line that cuts the parabola evenly. This is our axis of symmetry, passing through focus and vertex. In this situation, our axis of symmetry is a horizontal line, and equation of a horizontal line is always y equals to some value. Our directrix is a vertical line in this position, so x equals to some value is the equation. From focus to the down and up is equally 2p unit away. That we call this line is focal diameter, or latus rectum in Latin. Let's go ahead and see if p value is negative. In the same form of equation, if p value is negative, then our parabola is looking to the left. Our focus is always inside of parabola. Our directrix is always behind the parabola. and this is our vertex. From vertex to focus is p unit away. From focus to directrix is p units away. And from focus to up and down is 2p units. This line is focal diameter. This is directrix, and our axis of symmetry is the line that cuts the parabola evenly, passing through focus and vertex. So this is our axis of symmetry. Here, axis of symmetry is a horizontal line, so y equals to some value is the equation. Directrix is vertical line, so x equals to some value will be the equation. This is our focus, this is our vertex. And from focus to vertex, we count p unit to the right. And from vertex to directrix, we count p units to the right again. So first decide the orientation of parabola. You know that focus is always inside, and directrix is always behind, and p unit away. Let's go ahead and check some examples. Our example 1 is y equals to 16x. This equation is in the form of y minus k squared equals to 4p times x minus h. So let's put our equation in this form. So y minus 0 squared equals to 16 times x minus 0. So our 4p value is equal to 16. Our vertex is negative h comma negative k. So this is our negative h, this is our negative k value. So 0 comma 0. In this case, let's find p value, vertex, focus, directrix, and axis of symmetry. Our 4p value is equal to 16. So if we solve for p here, 16 divided by 4 is 4. Our p value is 4. We said that our vertex is 0 comma 0. This is y variable is squared and p value is positive, so our parabola is opening to the right. Our focus is here, roughly. Our vertex is here. This is our directrix, and this is our axis of symmetry. Our vertex is 0 comma 0. Our focus is p units away from vertex, which is 4 units to the right. If we go 4 units to the right, our focus will be 4 comma 0. So our focus is 4 comma 0. Our directrix is 4 units to the left. If we go 4 units to the left, this point will be negative 4 comma 0. And our directrix is a vertical line, so x equals to x coordinate of this point here. And our axis of symmetry is the horizontal line, so y equals to y coordinate of focus, which is 0. Our example 2 is y squared equals to negative 8x. This is again in the form of y minus k squared equals to 4p times x minus h. If we put our equation in this standard form, it's going to be y minus 0 squared equals to negative 8 times x minus 0. So we can tell 4p. Our 4p equals to negative 8. Our p value is negative 8 divided by 4, which is negative 2. Our vertex is negative h comma k, which is 0 0. Our parabola is looking left because y variable is squared and p value is negative. Our focus is inside. This is our vertex. Our directrix is behind the parabola, and our axis of symmetry is passing through focus and vertex. Equation of axis of symmetry is y equals to value because it's horizontal. Equation of directrix is x equals to some number because it's vertical. Let's start from vertex. Our vertex is 0, 0. Our focus is p unit to the left. It's gonna be 2 units to the left. So you take the absolute value of this because it's a distance. 2 units to the left is negative 2, 0. So that's gonna be our focus. Our directrix is 2 units to the right. So it's gonna be 2, 0. And x coordinate of this line, this point, is 2. And our axis of symmetry is a horizontal line, so it's gonna be y equals to y coordinate of the focus. Our example 3 is x squared equals to 12y. So this equation is in the form of x minus h quantity squared equals to 4p times y minus k. Let's put this in our standard form. X minus 0 squared equals to 12 times y minus 0. So we can tell that our 4p is equal to 12. Then our p is equal to 12 divided by 4, which is 3. Our vertex is negative h, comma negative k, which is 0, 0. This is x squared term. So our parabola is either opening upwards or downwards. Our p-value is positive, so it's going upwards. We know that our focus is always inside, and our directrix is always behind the parabola. Our axis of symmetry is passing through focus and vertex, cutting the parabola evenly. This is our focus, this is our vertex, this is our directrix, and this is our axis of symmetry. Axis of symmetry here in this case a vertical line, so x equals to value. Our directrix is y equals to some value because it's horizontal now. Our vertex is 0, 0. Focus is p units away from vertex, so 3 units above. If we go 3 units above, it's going to be 0, 3. So focus is 0, 3. And our directrix is 3 units below, which is going to be 0, negative 3. And y coordinate of this point is negative 3. And x coordinate of focus is 0. So directrix is y equals to negative 3. And axis of symmetry is x equals to 0. Example 4, x squared plus 16y equals to 0. Let's rearrange this equation. So x squared is equal to subtract 16y on both sides. And this equation is in the form of x minus h squared equals to 4p times y minus k. And let's rewrite this equation in our standard form. X minus 0 squared equals to negative 16 times y minus 0. Our 4p value equals to negative 16, so our p value equals to negative 4. And our vertex is 0, 0, negative h, negative k. This is x squared term, and p value is negative, so our parabola is looking downwards. Our focus is inside of the parabola. Our directrix is behind the parabola. Our axis of symmetry is passing through focus and vertex and cutting parabola evenly. This is axis of symmetry, this is directrix, this is focus, this is vertex. Our vertex is 0, 0. Our focus is p units below vertex, which is 4 units below, so 0, negative 4. Our directrix is a horizontal line, so it's going to be y equals to some value. Let's find this point. So it's going to be 4 units above the vertex, which is 0, 4. And y coordinate of this point is 4. Our axis of symmetry is a vertical line, so x equals to, it's the x coordinate of vertex, which is 0, because passing from the same point. So directrix is y equals to 4, and axis of symmetry x equals to 0. Example 5. X minus 2 squared equals to 8 times y minus 1. So this is in the form of x minus h squared equals to 4p times y minus k. And if we match, our 4p is 8. Just match the equations. So our p-value, if you solve p in this equation, 8 divided by 4 is 2. Our vertex is negative h, comma, negative k. So you're gonna negate this value, take the opposite. Negative 2 will be positive 2, negative 1 will be 1. So you go in the order of h, comma, k. X term is squared and p-value is positive. That means parabola is looking upwards. Our focus is inside. Our directrix is behind the parabola. This is vertex, and axis of symmetry is passing through focus and vertex. This is focus, this is vertex, this is directrix, this is axis of symmetry. Our vertex is 2, 1. Our focus is 2 units above vertex, p units above. So if you go 2 units above, it's going to be 2, 3. Our directrix is 2 units below. It's going to be 2, negative 1. It's a horizontal line, so y equals to y coordinate of this point. Our axis of symmetry is passing through the same point as focus, so x coordinate of this. Directrix is y equals to negative 1, axis of symmetry x equals to 3. Our axis of symmetry is the x coordinate of focus and vertex, which is 2. They are passing through the same point. Our example 6 is x plus 1 squared equals to negative 8 times y plus 1. Our equation is in the form of x minus h squared equals to 4p times y minus k. So if we match, this is our 4p. And negative 8 divided by 4 is negative 2. Our vertex is negative h, negative k. So negative h is negative 1, negative k is negative 1. This is x variable is squared and p-value is negative, so it's looking downwards. Our focus is inside. Our directrix is behind the parabola. This is our vertex. Axis of symmetry is passing through vertex and focus. So our focus is p unit below vertex in this case. So 2 units below. If we go 2 units below, it's going to be negative 3. And our directrix is 2 units above. So it's going to be negative 1, 1. So directrix is a horizontal line here, so y equals to y coordinate of this point, which is 1. Axis of symmetry is a vertical line, so x equals to x coordinate of focus or vertex, which is negative 1. Our focus is negative 1, negative 3. Our directrix is y equals to 1. Our axis of symmetry is negative 1. This time, given focus and directrix, let's try to write the equation in the standard form. Example 7. Our focus is 7, 0 and directrix is x equals to negative 7. This time, let's sketch what is given first. Our focus is 7, 0. Our directrix is x equals to negative 7. So negative 7 is further left from positive 7. So x equals to negative 7 is here. This is our directrix. Between focus and directrix is the vertex. So 7 units and 7 units away. So vertex is 0, 0. And we know that our parabola is opening through the focus. So this is the equation of y squared term, and our p-value is positive because it's opening to the right. So our equation is in the form of y minus k squared equals to 4p times x minus h. Our vertex is 0, 0, so h 0, k 0. And our p-value is from focus to vertex is 7 units. So y squared is equal to 4 times 7 is 28, and x minus 0 is x. So this is the equation. Our example 8. Focus is 0, 15. Directrix is y equals to negative 15. So let's sketch focus first. 0, 15. So y coordinate is negative 15, which is below the focus. Between focus and directrix is the vertex, and our parabola is opening through the focus. Our axis of symmetry is passing through both. So we go 15 units here and 15 units here. Our vertex is again 0, 0. And our equation is in the form of x minus h squared equals to 4p times y minus k. It's opening upwards, so our p-value is positive. Our vertex is 0, 0, so h is 0, k is 0. So we clean up, x squared is equal to 4 times p-value is 15, so 4 times 15 is 60, y. This is the equation. I hope you find this video useful. Thank you for watching.